Hello everyone. Today I am going to take the class about data compression. So in first unit of data compression, we can study about the lossy and lossless compression and the different techniques used in these lossless and lossy compressions. So the unit contains compression techniques in which we are classifying it as lossless compression and lossy compression and how we are going to measure the performance with the different models. So in this PPT we are going to see about the compression techniques and what are the codings we are going to use for these compression techniques. So main objective after studying this chapter, the students can be able to distinguish between the lossy and lossless compression and what are the different encoding method we are going to use. So first, what is a data compression? So storing an information with having the size as a smaller one, we can have a method of lossless and lossy methods. So data will be compressed into small data. So it can be a lossless or lossy method. Lossy methods classified as image, video, audio, that is JPEG, MPEG, MP3 audio, like that. Lossless methods are the text method. So we are going to use run length coding, Huffman coding, impulsive coding. So first lossless compression. So the data will be preserved. So original data will be preserved after compression and decompression process. So the data will not be have any damage. That is the lossless. So in this process, redundant data will be removed and added after the decompression. So first we are going to use the run length encoding, which is used as a simplest method for the compression. So it will have the combination of symbols and data will be represented zeros and ones. We can have more efficient data use using these symbols. So you are going to use the bit pattern like this. For example, B. So B has been repeatedly given for 9 times. So when we are going to compress it, the value will be given as B09. How many times A has repeated, how many times N has repeated, how many times M alphabet has been repeated. So original data, they will write in the zeros and one sequence. We can have the number of zeros. How many zeros? Number of one after that zero. How many zeros? After one. So we have to count that one combination and zero combination. Then we can compress it in the binary form. In the Huffman coding, we can have the frequency of the character. That is, for example, if we are taking any five symbols, we will assign some frequency of the symbol. Then we have to draw a tree according to the weight. So A, B, C, D, E, A is 17, B and C are 12, 12, D is 27, E is 32. Now we are going to combine the least number B and C, then combining the A with B and C. So it creates 41. Then we will have the A, B, C tree and D, E and E as combination. After that overall combination will be 100. According to combining this, we are going to assign the values zeros and ones. For example, you can see at the upper top bottom we will have code 0 and 0 for A. Similarly, if you are seeing for B, we can have 0, 1, 0. C 0, 1, 1. After that D 1, 0. E will be having 1, 1. So we have to draw the tree and mark the value zeros and ones. Next, encoding. So we have given the values as zeros and ones. After that, taking the text value, we will encode the value opposite as 0, 0, 0, 1, 0, 1, 0. Then we have to combine the value according to the given text, that is the Huffman coding. Decoding means given pattern 0, 1, 0, 1, 1, 0 will be converted to 0, 0 means A, 1, 0 means B, 0, 1, 0 means C. Like that we have to convert the value. Then we will have to convert it into text. In impulsive encoding, it is in a dictionary based encoding. So we have to create a dictionary with this table of strings. So for example, we will have two or three concurrent uh, values or bits. So we will compress into a strings of symbols. We can see, for example, first one passing B. So we are giving an uncompressed data A, B, A, B, 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 A, A, B, 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 A, A. So first we will take the value b. Next will be a. So like that we have to form a table. After forming this table, we have to refer the dictionary and we have to compress the data. For example, b, a, the 2b, 3b, 1a, 4b, 5a. How many times the character has been repeated? So in decompression, we will have the inverse process. So we have to extract the substance of the compressed data according to the dictionary. Then we can change the value. So in lossy compression methods, there will be the original information will be saved, but some of the data will be lost. For example, in JPEG, MPEG, and MP3, that is a joint photography experts group, moving picture experts group, and the MPEG audio player 3. So in this, they will have some of the data will be lost, not more than, but some of the data will be lost. So in image compression, we are using JPEG coding means a grayscale picture of a 3,07,200 pixel will be represented at different bits, and color picture will be represented by a different bits. So we will have the JPEG images classified into two blocks of pixel values. So for example, 888 pixels means how many rows we are going to have. For a JPEG grayscale example, 640 into 480 samples. So how we are going to convert this compression of the image? So we are giving the block image to the discrete cosine transformation. Then we are going to quantize the information. Then lossless compression. After that, compression image will be obtained. So in this discrete cosine transform, the transformation changes the values of the pixels to the repeated redundancies will be reduced. So how it is done? So 8 into 8 block means, for example, 20 values has been given. It will be combined into one grayscale. After that, it will be given to the pixel values. So after that, it will be quantized to the nearby values according to the quantization table. We can make the values to be reduced. After quantization, it will be given to the compression method so that we will get the lossless compression. So we will finally saw the result from 20 to how the pixels will be classified up to 0 by the table. So in video compression, MPEG encoding, it is used to compress the video. The motion of the picture will be in the rapid sequence of a set of frames in which each frame is a picture. So it will have some spatial combination and temporal combination of the frames. By compressing that video, we can have the each frame with the spatial compressing and set of frames with the temporal compressing. So, what is spatial compression and temporal compression? Spatial compression is each frame done with the JPEG modification. So, here the redundant temporal compression, we will have the redundant frames removed and we can see 30 frames per second for a TV with television. We can see the frames will be translated for the consecutive frames. So this is the frames example how the data has been transferred in the frame construction. So you can see from 1, 2, 3, 4. So it will be classified as IBBP. So then we can combine the frames and it can be transferred in the video. So in the audio compression, we can use the speech for we can use the speech signal, music signal with the compression of 64 kilohertz digital signal. We can have the music we need to compress in the megahertz signals. So it will be having the higher frequencies. So for that we can use predictive encoding and perceptual encoding. So in predictive encoding, differences between the samples are encoded instead of encoding all the samples. Some of the samples differences only will be encoded. So in perceptual encoding compression technique, it is used for the CD quality. So for this they will need some 1.411 megabits per second. Thank you.